Hey everyone, welcome back to Simple Learning AI. In our last video, we explored types of regression and classification. Today, we're diving into the brain of machine learning, neural networks. What are they? Why are they so powerful? Let's break it down step by step. What is a neural network? A neural network is a series of algorithms that mimics the way the human brain processes information. It's made up of layers of neurons, which are tiny units that process input and pass it forward. Think of it like this. Input data goes in, gets transformed through layers, and finally gives an output, like a prediction or decision. Example. When you upload a photo to Facebook and it tags your friend automatically, that's a neural network recognizing faces. Structure of a neural network. Input layer takes in data, like pixel values or numbers. Hidden layers, the thinking part, where magic happens. The network adjusts weights to learn patterns. Output layer gives the final answer, like, yes, it's a cat, or, this customer might leave. Each neuron multiplies inputs with weights, adds bias, then applies an activation function, like ReLU or sigmoid, to decide what to pass on. What is an activation function? An activation function is a mathematical function applied to the output of a neuron. It introduces nonlinearity into the model, allowing the network to learn and represent complex patterns in the data. Without this nonlinearity feature, a neural network would behave like a linear regression model, no matter how many layers it has. Activation function decides whether a neuron should be activated by calculating the weighted sum of inputs and adding a bias term. This helps the model make complex decisions and predictions by introducing nonlinearities to the output of each neuron. Types of activation functions. Linear activation function resembles straight line defined by y equals x. No matter how many layers the neural network contains, if they all use linear activation functions, the output is a linear combination of the input. Nonlinear activation functions. Sigmoid function. Sigmoid activation function is characterized by S-shape. It is mathematically defined as. This formula ensures a smooth and continuous output that is essential for gradient-based optimization methods. ReLU, rectified linear unit, function. ReLU activation is defined by this means that if the input x is positive, ReLU returns x, if the input is negative, it returns 0. Tanh activation function. Tanh function, hyperbolic tangent function, is a shifted version of the sigmoid, allowing it to stretch across the y-axis. Exponential linear units. Softmax function is designed to handle multi-class classification problems. It transforms raw output scores from a neural network into probabilities. It works by squashing the output values of each class into the range of 0 to 1, while ensuring that the sum of all probabilities equals 1. Soft plus function is defined mathematically as this equation ensures that the output is always positive and differentiable at all points, which is an advantage over the traditional ReLU function. How does a neural network learn? It learns through a process called backpropagation. Forward pass. Data flows through the network to produce an output. Compare output to actual answer. Right pointing arrow. Calculate error, loss. Backward pass. Adjust weights to reduce the error using gradient descent. Over time, the network gets better and better at making correct predictions. Types of neural networks. Feed-forward neural network, FNN, is a type of artificial neural network in which information flows in a single direction from the input layer through hidden layers to the output layer without loops or feedback. It is mainly used for pattern recognition tasks like image and speech classification. Convolutional neural networks, CNNs. A convolutional neural network, CNN or ConvNet, is a network architecture for deep learning that learns directly from data. CNNs are particularly useful for finding patterns in images to recognize objects, classes, and categories. They can also be quite effective for classifying audio, time series, and signal data. A recurrent neural network, RNN, is a type of neural network that has an internal memory, so it can remember details about previous inputs and make accurate predictions. As part of this process, RNNs take previous outputs and enter them as inputs, learning from past experiences. Where are neural networks used? Self-driving cars, detecting lanes, signs. Voice assistants, understanding speech. Medical, identifying diseases from scans. Finance, predicting stock movements. Art, creating music or images with AI. Neural networks power so much of what we use today, and they're only getting smarter. In future videos, we'll build one step by step using Python. So make sure to like, subscribe, and turn on the bell. Have a question about how they work? Drop it in the comments below. Before you go, let's answer the quiz from the previous video. I asked, is predicting someone's age based on their photo a regression or classification task? The correct answer is regression. Why? Because age is a continuous number, like 25.4 or 37, not a category like child or adult. So when an AI model tries to guess a numerical value like age, that's a regression problem. If we were instead grouping people into age brackets like teen, adult, or senior, that would be a classification task. Thanks for watching. See you in the next video on deep learning.